Kumar. Okay, very good morning, Abraham. See, in the yesterday's class, what we discussed here, see, we just started discussing about the work, power, and energy. See, in that topic, yesterday we discussed about the law of conservation of energy. And I tried to do a few problems based on this law of conservation of energy. I think you understood those problems. And yesterday I gave some more problems. I think you might have done those problems also. See, please every day what you have to do is that please revise and please revise as many sums as you can. Yes, good morning, Sai Praneeth. Please revise as many problems as you can. Okay, in the various sources. And see, today it is Sunday and today it is 1st of November. See how the days are running. Okay, we completed almost 1 month, and 1 month plus. Okay, and see regularly our classes are running from morning 6 to 7 a.m. Maybe in the between, okay, 1 or 2 classes we missed. Okay, but see every day we are running the classes morning 6 to 7. Okay, thank you for coming to my classes regularly. And see carefully, in today's class what I am going to discuss. Today's class we are going to discuss about what is called vertical circular motion. And see, apart from that one, see, yesterday I couldn't complete that power. So that power concept also we are going to discuss today. And see, apart from that, see carefully, today at 10 o'clock you will be having exam on the Newton's laws of motion. Okay, please kindly prepare for that one. And today regarding vertical circular motion, I am giving one worksheet because that is must. Okay, so apart from preparing for exam, okay, please try this worksheet also later on. Okay, now see carefully here. Let us start discussing about the power today. Okay, see yesterday that law of conservation of energy you might have understood well, I think. See, in the law of conservation of energy, what we got here, in the law of conservation of energy we have see the total energy is always constant. So the net energy is always constant. Means here the energy will change its forms, either from kinetic to potential and potential to kinetic. But the net potential kinetic are always constant. Okay, that is what we discussed in the last class. Okay, now see carefully, today we are going to discuss about power. Okay, it is written by letter P. Remember, power is a scalar quantity. See here, why the power is a scalar quantity? Because if power shows the work done per unit time. Work done is a scalar, time is a scalar. So scalar division with scalar is again comes a scalar. Okay, see carefully, see what is the power here? See, power is nothing but the rate of doing work. Okay, the rate of doing work. Okay, and one more important point. See, tomorrow we are going to start what is called center of mass chapter. We are going to start today. Okay, by today you please try to complete this work per energy chapter. Okay, so that tomorrow we can start the center of mass. So it will take 2 days time, and then collisions, so that is 3 days time. So like that we will continue. Our syllabus will continue like that. Okay, then see carefully here. What is power here? Power is nothing but the rate of doing work. Means nothing but, see, power is equals to work done by time. Okay, see, work done is what here? Work done is measured in joule. Time is measured in seconds. So therefore, see, what is the unit of power here? Power is equals to joule per second. And remember, 1 joule per second is known as 1 watt here. Okay, but remember, see, 1 watt is usually a smaller unit. So that's why they use a bigger units, like say 1 kilowatt. See, 1 kilowatt means what here? It is 1000 watt. Okay, and see, we also have here 1 megawatt. See, 1 megawatt means what here? 10 power 6 watts. Okay, and also see, apart from this, and see, we also have another one that is called 1 horsepower, 1 HP. So 1 horsepower is equals to, it is nothing but 746 watt. Okay, so usually we say 1 HP motor, 0.5 HP motor. See that motor, see that power represents what here? Means how much work it can do in a particular time. See, for example, see carefully, if a runner runs 100 meters in 10 seconds, if another runner runs the same 100 meters in 1 minute, then who is more powerful here? So definitely who covered the 100 meter in 10 seconds was the powerful person. Why? Because he did the work in the smallest time. See, for example, if I tell you to carry 10 buckets of water from the ground floor to the 5th floor, okay, see, you will carry buckets of water, then it will take how much time? Almost 1 hour time it will take to carry at least 10 buckets of water. Then at the same time, if I just turn on the motor, then it will take that water within 1 minute. Means who is powerful there? So it is nothing but the motor there. So here the power represents what here? So how much amount of work you are doing in a particular instant of time. So that is called power here. So the rate of doing work, that is what we will call. And see, apart from this, and see carefully, see, power is equals to work done by time we got. See, work done equal to what here? Force into displacement by time. But here, what is displacement by time here? Displacement time is velocity. Therefore, you can write, see, power is equals to F dot V. Oh, again here, see carefully here. So I represent it with the letter dot V. Why here dot here? See, the dot here represents what here? See, the power is a scalar quantity once again. And force and velocity are vectors here. So that's why F dot V gives what here? F dot V gives the power here. Okay, are you following what I am saying here? Okay, and also see carefully, we have another one, very important one. This is called average power. So remember, power is different from average power here. So remember, power is different from average power. See here, what do you mean by average power? Average power. See, average power is nothing but, see, it's nothing but the net work done. So, okay, it is nothing but the net work done in the total time. See, that is called as average power. See, usually the average power is represented like this. See, integral P dt by integral dt. See, what is the average power here? The average power is nothing but, see, P integral dt, integral P dt by integral dt. Means the power into time gives work done. So this is the total work done here. And see, this one is what here? This one is nothing but the total time here. The total work done by total time is known as average power. Please remember, power is different from average power. Okay, good morning, Srivasla. Okay, good. Now see carefully, this is called average power. Okay, see carefully here. See, let us try one problem. See, every time whenever you are solving the sums related to power, please always remember, see, whenever you are solving, see, always see carefully who is doing the work. So how much amount of work is done in how much time. So like that you have to do. Okay, see, for example, see, let us say, see, let us try one small example here. See, let us say a body of mass m, is lifted to a height h. Okay, is lifted to a height h. Okay, then what is the work done here? It is just lifted. See carefully, see here, what is the point number 1? Just lifted. Okay, just lifted. Okay, in time t. Okay, now tell me here, in this case, what is the work done here? See, the work done is nothing but mgh. Okay, the minus mgh only we need to write, but let me take the magnitude of the work done here. See, the work done equal to mgh here. Then say, what is the power here? See, power is equals to mgh by time here. Because see, in a time t is said. Okay, now see, let us take the same case here. Let us take the same problem. See, the same problem in this one. Suppose I lifted this body to a height h. Okay, I lifted this body to a height h. At the same time, by the time I lifted this one, see, by the time I lifted this one, what happened? It has got some velocity v. So it means that there are two things are happening here. Number one, it has got, okay, see, there is a gain in the potential energy, and also see, there is a gain in the kinetic energy also. See, are you following what I am saying here? Means you see, it has got some potential energy as well as kinetic energy, because it has got some velocity here. They were not telling me here what is the work done here. The work done is equals to mgh plus half mv square. They were saying what is the work done here. See, work done is equals to mgh plus half mv square by time taken. So this is what you have to see here. Keep carefully. Whenever you are solving the problem, see, be careful. See, what is the carefulness you have to take here? Means what is the total amount of work is done, that you should see carefully. and based on that in what time it has completed. So work done and time, work done and time. That is what you have to see here. And also please don't forget another formula, that is F dot V. That is also you should remember. Okay, so let us look at another problem, very nice and interesting problem. Okay, so today we are going to discuss vertical circular motion. Okay, after this problem I am going to discuss that one. Okay, so there's another very interesting one and very logical also. Okay, now see carefully here. So let us try to do this problem. See what this problem is that, see, let us say a body of mass m is there, a body of mass m is there. See here, see what is doing, a constant power P is acting on that mass. Okay, constant power P is acting on that mass. So that, see carefully what happened, its velocity changed from V1 to V2. See here, its velocity changed from V1 to V2. Okay, see carefully here. See, on a body of mass m, a constant power P is acting. A constant power P is acting on that body. Okay, so therefore what happened? Its velocity changed from V1 to V2. Let us see carefully here. When its velocity changed from V1 to V2, then calculate the distance traveled by it. You can see here what the question they asked is, calculate a distance or displacement. Either one, no problem. See, calculate the distance. Yes, that is the one. Come and see how to do this one. See, it's okay, there is a constant power is there, but see which one is changing here? The velocity is changing, means the body is getting accelerated continuously. So continuous acceleration is there. So therefore, see carefully here what we do. See, let us write down. See, power equal to F dot V. Can you write like that? See carefully, we can also write, see carefully here. See, power can be written as mass into acceleration into V. Can I write like that? And see carefully, we know that, see carefully, the acceleration is equals to dV by dt. So acceleration is equal to dV by dt. See here, there is no time they did not give. They gave in terms of distance and also they gave in terms of velocity. So let us convert this formula into like that. So dV by ds into, okay, ds by dt. Can I write like this? See, can I write like this? Because see, ds cancels. So dV by dt. But yeah, what is ds by dt? I think earlier we did like this one. ds by dt nothing but v. Therefore, the acceleration can be written as, see, v into dv by ds. Can I write like that? So let us substitute that acceleration here. Therefore, say what the power here? Power equal to m into v into dv by ds multiply v. So send this ds this side. Therefore, see p into ds equal to m into v square into dv. Okay, now see, let us integrate on both sides. This is from 0 to s because it has traveled a distance s. And say the velocity change from v1 to v2 here. Therefore, see carefully, p into s, 0 to s, is equals to m into, say what is the integral value of this one? The integral value is nothing but v cube by 3. That is from v1 to v2. Okay. Now see what we do. See, let us send the 3 this side. Okay. Let us send the p this side. Where we want s here. So therefore s is equals to, see here, m by 3p into, see, v2 cube minus v1 cube. That's it. Means substitute the upper limit and lower limit. So are you following, sir, what I am saying here? So therefore, see carefully what the distance traveled by it. See, the distance traveled by it is nothing but s is equals to m by 3p into v2 cube minus v1 cube. Okay, so are you following what I am saying here? Okay, good. Then see carefully here. So this is about power here. See here, what do you mean by power here? See, power is nothing but the rate of doing work. See, we can solve it in 3 different formulas, I said. Number 1, it is nothing but, see, power is equals to work done by time. That is one formula. And the second formula is what here? Is the power equal to F dot V. And the third formula, what is said here? So it is integral P dt by integral dt. Okay, see here as okay, we are having very less time. So in the less time we need to complete more syllabus. So I am just saying the important points what are needed. So you please try the problems. If you are not getting any of the problem, please kindly let me know that problem. Okay. So please write in the comment box. Okay, you want this particular sum. Then definitely I'll explain the next class. Okay, or whatever the sums you are not getting, please let me know in that comment box. Okay. So see, yesterday somebody said, see, yesterday when I am saying the class, in the 50th minute I wrote B, C like that. Okay, so that they mentioned. That's thank you for mentioning like that. So it's so good. Say like that interaction we must maintain. If you maintain like that interaction, then what will happen? That will help me a lot in improving my lectures, and also that will help you a lot in in clarifying your doubts. So two things will happen. Okay, thank you very much. Okay, now see carefully. Okay, see carefully here. Now see, let us discuss about what this is called vertical circular motion. So this is another very important one. Okay, you see carefully, vertical circular motion. Okay, so I think suppose yes, Dheeraj Ishwar, good morning. And say suppose for example, see we have what is that is called like a giant wheel. So you simply will say giant wheel. See, the giant wheel is what here? It is nothing but it's nothing but the best example for vertical circle. Okay, see, vertical circle means what here? See, earlier we discussed about the horizontal circular motion. Means on the plane it is rotating. On the horizontal plane it is rotating. Now see, we have this vertical circular motion. What is this vertical circular motion? See here, when it is rotating in the vertically means what here? It is rotating in the vertical plane. So that is called as vertical circular motion. See carefully in this one. In this one, see, let us say this is one vertical circle. See, observe this vertical circle. So this is a vertical circle, and see this is center of the circle. Okay, now here see what I did here. See, I took one string and I connect this one to a body of mass m. See, it is connected to a body of mass m here. Now see what I do, I give it a certain velocity. See here what I do, I make it into 4 parts. Let us call it A, this one is B, this one is C, and this one is D. So A, B, C, D, 4 points I chosen here. So this is the lowest point, this is the highest point, and this is the horizontal position. The BD are the horizontal positions. See carefully here, see when I am at the lowest point here, see let us say the velocity is VA. Suppose if I reached here, see my velocity is VB, and when I reached here, see the velocity is VB, VC. So here every instant what is happening here? See the velocities are changing here, and see by the time I came to this D, see my velocity is VD. See here every time, see what is happening here, see the velocity is changing or the speed is changing gradually, whether it may be increasing or decreasing, that we will see later. And the second thing, see carefully here, and one more important point, see this is string will be there. So definitely here, what is the string here? The string here will be, this is tension at A, and see if I come here, see this is a tension at B, the tension at C, this is a tension at D. So means here, see the speed is changing. The second thing is the tension is also changing here. So two things are happening. Okay, then see how to solve this problem. See, remember this one is based on the law of conservation of energy. We can solve these problems. And here in this one, I am going to say 3 important formulae. See, based on 3 important formulae, we are going to solve the entire situation. All the situations, whatever may be there, all the situations we can solve here. Okay, see, let us observe here carefully. For example, see, let us take another point E. Okay, this is the point E. Okay, see at this point E here, what is happening here? See, let us say this is a tension at E. Remember, tension is always away from the body. And say carefully, at point E, let us say the velocity is VE. Okay, are you following what I am saying here? Then say carefully, at say at the point E, let us say it is making some angle theta here. Okay. Okay, Uma Maheshwari, tension at A, tension B, tension C, tension D. Yes, this one is tension at E. The tension is also varying there. Okay, see T means here the tensions. Okay, here T means tension the string, and see carefully here the what is this one? V means what here? The velocity is nothing but speed at that instant. Other instantaneous velocity. Okay, now say let us see carefully at VE. Say let us observe here carefully. So this is the mg is acting in the downward direction. Okay, mg is acting in the downward direction. And see carefully here. Let us resolve this mg into two components here. See carefully, this is theta. This one is mg cos theta. Okay, and see this one will be mg sin theta. Okay, that mg sin theta we will see later. Okay, right now. So this one is mg sin theta. Okay, and also see carefully here. See by the time it reached here, from A to E, what happened? It has traveled some height here. See the position changed or not? See its position changed or not? Okay, see carefully here once again. See we are discussing about vertical circular motion. See in the case of vertical circular motion, see observe here carefully here. A body moving in the vertical plane. So here you can observe two things. Number one, the velocity is changing at every instant, and see the tension is varying at every instant. So now how we can calculate this? So that's why what I did here, I took one point here E. Say at point E here, what I did here, I resolved the the weight into two components. Okay, see what is the important equation what we need here? Number one. See by using these three equations, we are going to solve everything what is related to this problem, related to vertical circular motion. By using these three equations, we are going to solve everything. Okay, now see the number one. See, once observe carefully, this is the tension E, this is mg cos theta, and see this is the velocity VE. Means here, who is causing the centripetal force here? Means here that tension E minus mg cos theta is equals to mve square by r. So this is the first equation what we require. Say the tension E minus mg cos theta is providing the necessary centripetal force to move in a circular path. So therefore what is the first equation we got here? Te minus mg cos theta is equals to mve square by r. Okay, that's the first equation. Now see the second equation. See carefully here. Here the velocity is VA. Here the velocity is VE. See here, by the time the velocity changed here, what happened? It has raised a certain height here. Means what here? The loss in kinetic energy is equals to the gain in potential energy. So we can use the law of conservation of energy principle here. See, let us write down that one. See here. The loss in potential energy is equals to gain in the loss in kinetic energy is equals to the gain in potential energy here. So what is the loss in kinetic energy here? Means it is nothing but say half mve square minus, because that is the final kinetic energy. And so what is the initial kinetic energy? Half m VA square is equals to, see here it is going from here to here, means it is nothing but mgh. Okay, the gain in potential energy. So therefore see what you can write here. See you can write here, see VA square minus VA square is equal to 2gh. See, this is the equation number 2, what we want. So this is the equation number 1. See, what is the equation number 2? See, VA square minus VA square is equal to 2gh. Okay, are you following so what I am saying here? Okay, and see one more important point here. See here, so it is going away from, so this is negative here. Then see this one is negative here. So therefore let us do one thing here. This can be written as, See, VA square minus VE square is equal to 2GH. So equation number 2. Okay. You can now see the third equation. See, what is the third important equation we require? See here, we range it from here A to E, so we reach a certain height H. So how to calculate this H here? See carefully here. See here, see the third important point here. See, let us construct one triangle here. See, let us construct one triangle. See, this one is the radius R here. So this is the radius R here. So radius R. See, we raise a certain height, means this one is how much here? This one is R minus H. And see, this one is theta here. Okay. So therefore now see, observe here carefully. What is the cos theta value? See, what is the cos theta value? See, cos theta is equals to R minus H by R. Therefore, see, what is the R minus H here? See, R minus H is equals to R cos theta. So therefore, see, what is the H value here? R minus R cos theta. So therefore, what is H here? H is equals to R into 1 minus cos theta. So there is the third equation. Okay. See carefully, there are three equations which are going to use in solving all the problems related to vertical circular motion. You see, once again, see carefully what we have here. See here, the three equations are what? One is TE minus mg cos theta equal to mVE square by R at this point. Means if the point changes, automatically everything will change. And the second point is what here? VA square minus VE square equal to 2GH. Okay, that is because of the change in kinetic energy. And see the third one is what here? See here, it has reached a certain height H here. So therefore, see what is the H here? H is equal to R into 1 minus cos theta. Okay, see carefully. I'll do one thing here. I'll rub this top part. Okay, this one is vertical circular motion. Okay, say for reference here, what I do, I'll write the three equations here. Number one, what we got here, see TE minus mg cos theta is equals to mVA square by R. This is the first equation. And the second equation, what we got here, see VA square minus VA square is equal to 2GH. That is the second equation. And the third equation is what here, H is equals to R into 1 minus cos theta. That is the third equation. Okay, there are three equations which I am going to use in solving the problem. See, let us, okay, I'll rub this part. Okay. Okay, now, see, now observe here carefully. Let us do one thing here. From, see, let us take 2 and 3 equations. See, from 2 and 3, see, from 2 and 3 equations. So let us substitute the H value over this one. See, let us substitute the H value over this one. Then see what we will get here. See, VA square minus VA square is equals to 2GH into 2JH, okay, 2JR into 1 minus cos theta. Can I write like that? Okay, can I write like that? Okay, are you following what I am saying here? Okay, see, let us say this is the equation number 4. The equation number 4. Okay, now see carefully. See, let us first what we'll do. First, let us derive the minimum condition. Okay, see, let us first start with the minimum condition. So, minimum condition means what you see here. You need a minimum certain velocity at the lowest position, and you require the minimum velocity at the highest point also, so that it will continue in the vertical circle. So first we will take the minimum condition. See, in the minimum condition what we will do, so we will take the tension at C, mean the TC value we will take it as 0. That is the minimum condition. See, it may or may not be 0. See, the tension, see, remember the velocity should not be 0. The VC should not be 0. If the VC is 0, then what will happen? It will rise and it will fall. So that is called slack. So slacking of the string means what here? It will reach certain height, then it will fall because its velocity becomes 0. Remember, the velocity at C is not equal to 0. Okay, that's the first important point. The velocity at C is not equal to 0. Okay, but see what the minimum, see please write down. See, what is the important one here? See, the minimum condition. Okay, minimum condition. So, what is the minimum condition is that? See here, what I'll do, I'll take, see the minimum condition what I'll do is that, see I'll take the tension at C is equal to 0. See, let us take this one here, let us take this one here. See, the tension at C is equal to 0 means what you see, it started from A, it went up to C. So by the time it went up to C here, what is the angle theta here? The theta value is nothing but 180 degrees. The theta value is 180 degrees. So let us rewrite this first equation. See carefully here, Tc minus mg cos theta is equals to mvc square by r. Because see at the point E I have written that one. See at point C I have written the same formula. But see here, see it started from A and it went up to C. Means what here? The angle it covered is how much here? It is nothing but the theta value is 180 degrees. So therefore let us substitute that one here. Therefore see 0 minus mg. See what is the cos 180 value? Cos 180 degrees is minus 1. So therefore see minus 1 if I substitute here, then see mvc square by r. There was a minus minus plus, mm get cancelled. Therefore, see what is the Vc square? Vc square is equal to Rg. Therefore, see what is the Vc value? That is root over Rg. See, remember, this is the minimum velocity at the highest point. It's a minimum velocity at the highest point. See, what is the minimum velocity required at the highest point? It is nothing but root over Rg. So root over Rg is the minimum velocity at the highest point. Okay, see, are you following what I am saying here? Okay, see, when you got this one, when the tension at C is 0. So if the tension at C is not equal to 0, then definitely the Vc value is more than Rg. If the Vc value is less than Rg, means definitely it doesn't complete this 180 degrees at all. Means it will fall somewhere here only. Okay, so are you following what I am saying here? Okay, good. Then see carefully, the Vc value is how much? So let us write down here. See, the Vc minimum is root over Rg. Okay, so you know the Vc value. See, let us do one thing here. Okay, see, I rub this point. Okay. Okay, so now we are going to get everything. Now we are going to get everything by using our 3 equations. Remember that. So let us do one thing here. Let us take this equation. So let us take the equation number 4. See here in the equation number 4. See, let us take say from C to A I traveled. Say from C to A I traveled. Say when I travel C to A, say now tell me what is the theta value I travel. It is 180 degrees. Okay. Then say carefully. So this is from C to A means what is the initial velocity? Initial velocity is C. The final velocity is A. Therefore, see what I can write is Va square minus Vc square is equals to 2gr into 1 minus cos theta. Can I write like that? Okay, see Vc value you know already. The minimum value is how much here? Root over Rg. Let us substitute here. See Va square minus Rg is equals to 2gr into 1 minus of minus 1. Why 1 minus of minus 1 here? Tell me. Why 1 minus of minus 1? Why? Because see cos theta, see cos 180, cos 180 is minus 1. So 1 minus of minus 1 is how much here? It is nothing but 2. So 2 into 2, 4 gr, and this one is Va square minus gr. They will send this gr this side. They will say what is Va square? See Va square equal to 5 gr. They will say what is the velocity at A? It is nothing but root over 5gr. Okay, so are you following what I am saying here? Yes, very good, Dheeraj Ishwar. So therefore, see Va is equal to root of 5. That means what? At minimum velocity. See what is the minimum velocity at the lowest point? See carefully, Va equal to root of 5gr is what here? See minimum velocity at the lowest point. Okay, this is the minimum velocity at the lowest point. Okay, are you following what I am saying here? So therefore, say let us write down here. Let us write here. See what is the Va value? See the VA value. See, remember this is VA minimum. So this is the minimum value. See VA value is how much here? Root over 5GR. Okay, either 5RG or 5GR. Okay, so are you following what I am saying here? So this is very, very important. So let us try to calculate. So let us try to calculate the velocity at B. Come on, please calculate that one. So use this fourth equation. So calculate the velocity at B. Come on, do it. Please try that one. So calculate the velocity at B. See, okay, by the time I'll rub this one. See, velocity at B you need to calculate. So what is the velocity at B? Okay. Okay, see velocity A is root over 5RG. Okay, then see what is the velocity at B? Let us use this equation. So use this equation, find out. Okay, so use this equation, find out. See carefully, let us try this problem. See carefully, I am moving from A to B. So this is the final velocity, this is the initial velocity. So they will say, how can I change this formula here? See VB square minus VA square, VB square minus VA square is equals to 2GR into, so minus 2GR into 1 minus cos theta. Why minus 2GR here? Why minus 2GR here? Because see I am moving up here. Okay, are you following? And see here, see how much angle I covered here. See I covered an angle 90 degrees here. And see what is the cos 90 value? So the cos 90 degrees is equals to 0. Cos 90 value is 0. So they will not tell me. Very good Sai Pranit, good. Very good Dheeraj, good, very good. So they will not tell me what is VB square? VB square, see what is VA square here? It is nothing but 5RG. Okay, this is nothing but 2RG into 1. Because see cos 0 is 1. Okay, this is minus, sorry. Therefore, see what is VB square? See 5RG minus 2RG. It is nothing but see VB square equal to 3RG. Therefore, see what is the velocity at B? It is nothing but root over 3RG. Okay, so what is the velocity? What is the velocity at B here? That is root over 3RG. See here, please remember. See, this is the case when the velocity at A is root over 5GR. Suppose if the velocity at A is not root over 5GR, means it will be some other value, then definitely the VB value different, the VA value, the VC value different. So everything will be different. Okay, so based on the minimum velocity, or based on the velocity at the lowest point, we need to do that sum. Okay, see now another important thing we need to calculate. See, anyhow we know that the tension at C is 0. I mean that is the condition we have taken. See the tension at C, in the first case what we did, we took it as a 0. Now let us try to calculate tension at A. What is the tension at A? See, let us use the equation number 1 now. That to find the tension at A. See how to do that one. Okay, see I am rubbing this part. Okay, see this velocity we got it. Okay, the velocity part we got. Now we are going to do the tension part. See how we are going to find the tension in the string. See, we need to find the tension at A. See, carefully, tension at A minus mg cos theta is equals to mva square by r. mva square by r. Now see, I am at A. See, I am at A means what is the angle theta? The theta value is 0. See, I am at A means what is the angle theta? The theta value made is 0. So therefore, now tell me what the tension at A, it is nothing but say mg plus m by r into. So what is the V value? Oh sorry, this is VA. Because if velocity at A, we wanted to, yes, very good Dheeraj, good, correct. So what is the VA square value here? It is nothing but 5GR. There was the RR get cancelled. There was what is the tension at A? The tension at A is equal to 6 mg. Okay, see we got the tension at A. Come on, can you calculate the tension at B? What is the tension at B? See here, see how to calculate tension at B. See carefully here. TB minus mg cos theta. Wait, have you got the velocity at B first of all? What is the velocity at B? Root of 3gr we got it. Yes. See the velocity at B is root of 3gr that we already found. Now see carefully here, the TB minus mg cos theta equal to m into Vb square by r. See carefully, see it started from here, it went up to here, means here what is the angle it has covered here? See the angle covered by it is theta is equal to 90 degrees. See the cos 90 degrees is how much here? It is nothing but 0. See here cos 90 value is 0, means what here? See the tension at B is equals to m by r into Vb square. What is the Vb square? Very good Dheeraj. It is nothing but 3gr. There was the RR get cancelled. So tension at B is equal to how much here? It is nothing but 3mg. Okay, so are you following what I am saying here? See here we could calculate the tension at any instant of time. See here we can calculate the velocity at any instant of time. If you can do those things, then every problem will be quite easy in the vertical circular motion. Okay, let us try one or two problems based on this one. So always see what we have to do is that, see, just keep it in mind those three equations what I gave. See Te minus mg cos theta mv e square by r. And see Va square means Va square is equal to 2gh. And the third important thing is that what is the third one? See, h is equal to r into 1 minus cos theta. See, if you can remember these three equations, the sums will be very, very easy. Okay, say regarding string. Suppose sometimes they may give like cases like suppose they'll say one sphere will be there. In that sphere they are rotating another body, another small sphere. See, in that case what we have to do, instead of tension, we should take normal reaction. Okay, instead of tension what we have to do here, we have to take the normal reaction there. Okay, so let us try one or two problems, and there is another one is also there, that is called as a constant velocity. Okay, that case also we will discuss. Okay, good. Okay, please remember, see this vertical circular motion is another very, very important aspect. So especially in the IIT and NEET point of view, definitely questions are coming from this part. So that's why please follow it carefully and please try to do as many sums as you can. So I gave around 10 problems in the worksheet. Okay, please try those 10 problems. Okay, whatever the sum you are not getting, please let me know through WhatsApp, or please use the comment box. Please put some comments there. Okay, see, comments will help me a lot, and that will help you also a lot. Okay, either way. Okay, so it means that either way means what? You can clarify your doubts, that is publicly. And the second thing is that the means I'll come to know that whether you are understanding or not. Okay, are you following what I am saying here? Okay, now see carefully. Okay, so let us say see carefully here in this problem. Let us say the mass they gave is 5 kg. Take the g as 10 meter per second square, and see here the radius of the vertical circle they gave is 2 meter. The radius of the vertical circle they gave is 2 meter here. Okay, now see what the question they are asking is that, suppose if velocity at A, okay, see the velocity at A is root over 7 rg. Okay, see velocity at A is how much here? They gave root over 7 rg. Then find velocity at B, velocity at C. Okay, and see tension at A, tension at B, tension at C. You know already what is tension, A, B, C points. That's why I am not mentioning here. So you need to calculate all these things. And also see tension at E when theta is equals to 60 degrees. Okay, please try. Please do this one. Come on, please follow in an order. Please follow in an order. And please try. Come on, please try. Okay? Wait, by the time I will fill the ink here, I think ink is completed. Okay? Please try this problem. See here what they gave here. See the velocity A. See the velocity A they gave is root of 7 rg. And the velocity A is root of 7 rg. See here what the question they are asking. Find the velocity at B. Come on, first tell me what the velocity at B. First, come on, everyone. Okay, first type one by one. See here what the velocity at B. Okay, come on, please type. Please type what are your answers. Okay, come on, are you getting the answers or not? Come on, do type one by one. Please type one by one answer. Okay, please type one by one answer. So please do it. So see, your interaction with me is very, very important. Whether you're getting it wrong or right, whether you're getting wrong or right, see, your interaction with me is very, very important. Okay, okay, now see carefully here. See, what is the velocity at B here? See, remember, see here, see, I think you know this circle. This one is A, this one is B, this one is C. Okay, now see, and see, it is rotating, the radius they gave. Okay, say root of 7 rg they gave. See, first let us calculate the velocity at B. Good. Velocity at B 10 meter per second. D is very good. See, let us try. See carefully here. See what we will do here. See here what we have. VB square minus VE square is equals to. See what the formula we have. See, it is nothing but 2GH. See 2GR into 1 minus cos theta. That is the formula to be applied here. Yes, very good. Root 60, root 6GR. Okay. See, remember, see, this one you should take it as negative. Why? Because see, you are going from A to B. You are going from A to B. See, when you are going from A to B, see carefully here. What is the theta value? See, the theta value is 90 degrees. The theta value is 90 degrees there. Therefore, see here, what is the VB value? See, VB minus VE square. Oh, here, sorry, this is VA square. See, what is the VA value? Root of 7 rg means 7 rg. VA square means 7 rg equal to minus 2gr into 1 because see, cos 90 value is 0. So, therefore, see, what is the VB value? Means 7 rg minus 2 rg. Means here VB is equals to 5 rg. VB square. VB square. So VB square equal to root of 5 rg. Okay. I think see Sai Pranidhi, you have written root of 6gr. Please check your answer. Please check your answer. Okay. See carefully. See VB equal to root of 5 rg. Okay. It's tension at the no. First, have you calculated VC? Okay. Good. Good. Very good. So therefore, see VB is equal to root of 5 rg. Therefore, see what is the VB value? See root of 5 into 2 into 10 means it is nothing but 10 meter per second. See what is VB value? VB value is 10 meter per second. Okay, please check your answers. Please check your answers. Okay, how Dheerajeshwar you can write VB value you have written 10 and you have written VC is root 60. Root 60 means how much? 860. Okay, good. So less than 10 only you got. Okay. Then see carefully here. So what is the VC value? See again, let us take VC square minus VA square equal to minus 2GR into 1 minus cos theta. Why? Because we are going from A to C. And see carefully, what is the theta value? Theta value is 180 degrees. And cos 180 value is how much here? Minus 1. Therefore, say what is the VC square? Is nothing but VA square means 7rg minus 2gr into 1 minus of minus 1. It is nothing but minus 1 means plus 2 means 7rg minus 4gr means nothing but 3gr means here VC square equal VC equal to root of 3rg. Okay, see let us substitute here, means that 3 into 2 into 10 means nothing but root 60. Very good Dheeraj, very good. Okay, good Dheeraj, you are correct. Good. Root 60 meter per second is the velocity at c. Means that we got the velocity at c, that is root 60 meter per second. So are you following, sir, what I am saying here? Are you following? Yes, very good, Sai Praneeth. Good. Yes, Subbarao. Okay, good morning, sir. Okay. And now see carefully here. Now come and try. Come and try the next one. Come on, please try the next one. See, find the tension at A. See carefully. See, regarding velocities, we have used this formula. Come on, you should know how to use this formula. You should know how to use this formula. Okay. See, what is the formula you used here? Vb square means Vs square equal to 2gr into 1 minus cos theta. That is the formula we used here. Okay. Okay, good. And now see, let us calculate. Okay, I think you understood this. So let us try to calculate the tension at A. Now, how to calculate the tension at A? Okay, so are you following what I am saying here? See, tension at A means at this point. Okay, see, what is the formula we know? See, we know that, see, tension at A minus mg cos theta is equal to mva square by r. Okay, so do you remember this formula? Okay, let us use that formula here. See carefully, at A means the theta value is 0. So therefore see carefully, TA is equals to mg plus m by r into what is Va square? It is nothing but 7rg means mg plus 7mg means nothing but 8mg. That is tension at A. So 8 mg means here tension A is equal to how much here? See, 8 into mass is 5 kg. 8 into 5 into what is the G value? 10 means 400 Newton. So tension A is 400 Newton. Okay, what is the Dheeraj Ishwar has written? Tension at C. Good, very good. Okay, see, have you got it? Okay, good. Now see the next one here. See, tension at A you got. Now tell me what is the tension at B? See carefully, tension at B, TB minus mg cos theta is equals to Vb square by r. Okay. So therefore see carefully here. See here, you travel from A to B means what is the theta value? See, theta value is 90 degrees. And what is the cos 90? Cos 90 is 0. Therefore see tension B is equal to how much here? Say m by r into Vb square. What is the Vb square you got here? It is nothing but Vb square is nothing but 100. Okay, see here, what is the mass here? 5. What is the radius here? 2 into 100 means the tension at B is equals to 250 Newton. Well, I think tension at B, what is the answer you written? Yes, good, Dheeraj Ishwar. Correct. Okay, good. See, the tension at B is equal to how much here? 250 Newton. Tension at B is equal to 250 Newton. Very good. Oh, here theta value is 60 degrees here. Okay. See, are you following what I am saying here? Are you understanding, sir, what I am saying here? Good, very good. And so, what is tension at E? Okay. Adiratnam. Okay, good. What is the tension? What is the TV? The tension at C. Okay, good, very good. Okay, please remember, see, tension at C, let us write in Tc minus mg cos theta equal to mvc square by r. Okay, so I'll rub this part. Okay, very good. Everyone is doing the sums. Good, that's good. Okay, now see carefully. I say I travel from A to C. Okay, I travel from A to C means here, what is the theta value here? The theta value is 180 degrees. And cos 180 value is how much here? -1. So therefore see, Tc plus mg is equals to m by r into Vc square. What is Vc square? It is nothing but 60. Therefore see, Tc is equals to, what is the mass here? Say 5 by 2 into 60 minus mg, nothing but 50, means here 150 minus 50. Oh, very good. Very good. Tension at C is equal to 100 Newton. Very good. Some of you have written that answer. Very good. Tension at C equal to 100 Newton. See, are you following, sir, what I am saying here? Are you understanding? Very good. You understood it. Good. Now see, let us carefully see at theta is equal to 60 degrees, what the tension in the string. When the theta value is 60 degrees, I think Dheeraj Eswar has written the answer. That's good. That's yes. Okay, good. Let us check. Very good. Okay. See the problems in this one. See, problems related to vertical circular motion you can solve just by using a simple the three equations whatever I told. If you can use those three equations properly, you will get the answers. Okay. So let us try. See, but first you should know what is the velocity at E. The first thing what you have to do is that you have to calculate velocity at E. See carefully here, VA square minus VA square. Okay, VA square minus VA square equal to 2gr into 1 minus cos theta. That's the first thing. And so you are going up. See, this is E. So you are going up means you should take it as negative here. And so what is VA square? VA is root of 7rg. Means how much we got here? Root of 7 into 2 into 5. Means this one is root 70. Am I correct? So 2. Oh sorry, this one is 10. See 7 into 2 into 10. So root over 140 here. The VA value is root over 140 here. Okay, so therefore see carefully here. See VA square. What is VA square here? Nothing but 140 minus what is VE square that we don't know. Is equals to minus 2 into 10 into 2 into 1 minus of what is the cos 60 here? 1 by 2. Okay, so therefore see carefully what is VE square? So VE square equal to, oh already I did minus here. Again no need here. Okay, so therefore see carefully 1 minus 1 by 2 is 1 by 2. Therefore see 2 get cancelled. There was a 140 minus 20 means a 120. There was a what the VE value. It is nothing but root over 120 meter per second. There was a next what we have here T square. So T minus mg cos theta is equals to mv square by r. Okay, therefore see what is the TE value means a mg cos 60 degrees plus m by r into VE square, that is 120. So therefore see mg, what is the mass? 5 into 10 into 1 by 2 plus what is the mass? 5 by 2 into 120 means here this one is how much here? 25 plus 300. There was what is tension at E? That is 325 Newton. Ah, very good Dheeraj. Good, you got it. Good, very good. Say 325 Newton is the tension at E. Okay, see, are you following what I am saying here? Okay, good. See, I hope you understood this one. See, you be careful. See, when you are solving the problems. See, you be careful when you are solving these problems. See, if you have in mind all these formulae, then the problem solving will be quite easy. See, let us quickly try one more sum here. See, let us quickly try one more sum. Okay. See, let us quickly try one more sum. See carefully, let us say this is the surface. And say let us this is one hemisphere here. Say this hemisphere, let us say they are given the radius is r here. Say a body of mass m is kept here. Remember this one is very smooth one. A body of mass m is kept here. It just released. Just released means what here? The initial velocity is 0. And now see carefully here. Say by the time it reaches certain theta, now here he is saying that it will leave the vertical circle. means it goes out of the circle. Okay, then find theta. See carefully here what he has given here. See, this one is a smooth sphere, smooth hemisphere. See, on the hemisphere, see what he did, he kept one mass here. So what happened to mass? The mass will slide. As the mass will slide and it will fall. See, at one angle it is falling. Now he is asking what is this theta here? Are you following what I am saying here? Let us try that one. Come on, please do it. See here, once observe carefully. These are mass here. Therefore, see what you will get here. See, this one is mg. See, this one is theta. So resolve into components. This one is mg cos theta. This one is mg sin theta. And see, it has got some velocity v. And also see carefully here. The normal reaction is how much here? N here. Okay, so let us write our equations. See what are the equations we got here. See, by the time it came down here, see it reached certain height h here down. Okay, so are you following what I am saying here? So number 1, see carefully here, mg cos theta minus n is equals to mv square by r. That's the first point. Okay, and the second point is what here? See, it has got some velocity here. Means I say why that velocity it has got. See, there is a loss in potential energy. So loss in potential energy is equal to gain in kinetic energy. Means let us try to write down v square minus u square is equals to 2gh. And see, we also know that I say h is equals to r into 1 minus cos theta. See, this formula we already know. See that h with respect to theta. So therefore see carefully here, u is 0. Therefore see what is the v square value? 2gr into 1 minus cos theta. So that is the second equation we got. Okay, now see, observe here carefully here. Now it is leaving it. It is leaving it. Leaving it means what? It is not in contact with that one. So non-contact. Non-contact means what here? So the n value is 0. So let us substitute. See, this is the equation number 1, the equation number 2, and the equation number 3. See, it has lose the contact. Lose the contact means what? The n value is 0. Let us substitute there. Therefore, see, mg cos theta is equals to, see, mg cos theta is equals to n value is 0. Therefore, say m by r into, what is the v square value? 2gr into 1 minus cos theta. Okay. So therefore see carefully here, RR get cancelled, MM get cancelled, therefore see G cos theta is equals to, GG also can be cancelled, GG also can be cancelled, therefore see cos theta is equals to, so 2 into 1 minus cos theta. Okay, so therefore see carefully here, cos theta is equals to 2 minus 2 cos theta. Therefore, bring the 2 cos theta this side. So 3 cos theta is equals to 2. Therefore, cos theta is equal to 2 by 3. Means what is the theta value? It's nothing but cos inverse 2 by 3. Okay. See at what angle this mass will leave the hemisphere? It's nothing but say theta is equal to cos inverse 2 by 3. See at this angle it will leave it. Okay, so are you following what I am saying here? See, this is the advantages of vertical circular motion sums. Means in the vertical circular motion sums here, you can solve just by taking the 3 important things. See the tension or the normal reaction, and the next one is its velocity, and the next one is the h is equal to r into 1 minus cos theta. If you can remember these 3 equations, if you can know how to apply these equations in the problems, then you can solve all the problems very easily. Okay, I hope you understood this one. Okay, thank you everyone. Okay, this is Vijayam Physics classes. Okay, please share to your friends, please inform to your friends, and please let them use these classes for their benefit. Okay, thank you everyone. Okay, bye to all of you. Okay, we'll meet tomorrow. Tomorrow we'll start center of mass. So by today you please complete the work per energy chapter, and see next week, next Sunday, we are going to have a test on friction and circular motion. And see, today we are having a test on Newton's laws of motion. By 10 o'clock it is available in the YouTube. So 10 o'clock you can download that paper and please write that answers within 1 hour of time and please send them to me. Okay. Okay, see, they are available throughout the year. Those papers you can solve at any leisure time after your complete preparation. Okay. Okay, thank you everyone. Thank you. Bye bye to all of you. Okay, tomorrow we'll meet. Okay. Okay, 10 o'clock we'll meet.